Out there in the vast quiet of space, there are explosions so powerful, so unbelievably violent, that they can literally outshine entire galaxies. It's this incredible dance of destruction and creation, and today we're going to dive into the most extreme example of this, the hypernova. So you've probably heard of supernovas, right? The incredible, explosive deaths of massive stars. I mean, they're the titans of the cosmos when it comes to raw power. But what if I told you the universe has something even crazier, something far more ferocious up its sleeve? Really, what could possibly be more powerful than a supernova? Well, the answer is a hypernova. And look, this isn't just a slightly bigger bang. We're talking about a completely different league of explosion. A hypernova can be 10, even 100 times more energetic than a supernova. To put it simply, it's the difference between a firecracker and a thermonuclear bomb. Yeah, it's that big of a jump. Okay, so you have to wonder what in the universe could possibly power something like that. The secret, it turns out, isn't just about having a big star. It's about the very specific and frankly terrifying way it dies. So let's get into it. Let's break down the anatomy of what scientists call a collapsar. Think of it like a recipe for the biggest firework in the cosmos. Step 1, you need a truly massive star. We're talking at least 30 times the mass of our sun. When its core collapses, it doesn't stop at becoming a neutron star. Nope, it collapses so completely it goes straight to a black hole. And because that original star was spinning, this new black hole is spinning like crazy. All the material falling into it gets whipped up into the superheated disk, which then acts like a cosmic bazooka, launching these two insanely powerful jets of plasma that just rip through the rest of the star from the inside out. Boom! And that exact moment the jet bursts out of the star, it creates this incredible signature. It's called a gamma ray burst, or a GRB. For just a few seconds, this focused beam of pure energy is so bright it can outshine pretty much everything else in the universe, at least in gamma rays. It's the hypernova's calling card, and it's aimed like a laser-guided weapon across space. And yeah, weapon is definitely the right word. The amount of power we're talking about here it's just mind-boggling. It's enough to cause absolute devastation on a galactic scale. Let's try to wrap our heads around this number, 10 to the power of 53 ergs. What does that even mean? Well, it's more energy than our own sun will produce over its entire 10 billion year lifespan, all released in just a few seconds. It's enough raw power to briefly outshine all the hundreds of billions of other stars in its own galaxy. Just wow. So you might be wondering, what happens if you're unlucky enough to be in the path of one of these things? A direct hit from a gamma ray burst, even from thousands of light years away, would be, well, apocalyptic is the only word for it. The radiation would just shred a planet's atmosphere, its ozone layer, toast the surface. You're talking about a guaranteed mass extinction event. And listen, this isn't just some sci-fi scenario. Some scientists actually think that one of the biggest mass extinctions in our planet's history, the Ordovician extinction about 450 million years ago, could have been caused by a GRB from a hypernova that just happened to be a little too close for comfort. It's a really chilling thought, right? A reminder of how vulnerable we really are. Okay, so at this point, it's easy to just write these things off as pure cosmic monsters, right? Just forces of total destruction. But this is where the story gets really interesting. What if I told you that all this unimaginable violence actually has a purpose? That it might even be essential for, well, for us? Because it turns out a hypernova isn't just a destroyer, it's also a creator. It's a cosmic factory. Deep inside that chaotic explosion, it's busy forging some of the rarest and heaviest elements in the entire universe. The secret sauce here is a mechanism called the R process that stands for rapid neutron capture. Now, this process can only happen in the most extreme places in the universe. You need insane temperatures and a ridiculous density of neutrons all packed together. And wouldn't you know it, that chaotic, messy, neutron-rich stuff getting blasted out from the hypernova's black hole, it's the perfect place for it to happen. So what kind of stuff does the R process make? We're talking about the real treasures of the periodic table, things like gold, platinum, uranium, even elements that are essential for life here on Earth, like the iodine in our bodies. All of it was forged in the heart of one of these cosmic infernos. Think about that for a second. The gold in a wedding ring, something that symbolizes permanence and stability, was almost certainly born in the unimaginable violence of a hypernova. It's just an incredible connection, right? These ancient, distant catastrophes are literally part of our lives, right here, right now. So here we are with this amazing cosmic paradox. You have this single event that is powerful enough to wipe out life across an entire chunk of the galaxy, but it's also the very thing responsible for creating the building blocks of new planets and maybe even new life. It's like two sides of the same coin. The very same jets that create those deadly gamma ray bursts are also driving out the material that forges heavy elements. The same power that can sterilize a world is also seeding the galaxy with the raw materials for the next generation of stars and planets. It's the ultimate cosmic cycle of death and rebirth. And if you zoom out, this process was even more important in the early universe. Hypernovas from the very first stars were crucial. They helped end the cosmic dark ages by blasting everything with radiation. They were the first to pollute the universe with heavy elements, adding them to the pure hydrogen and helium from the Big Bang. You could say they literally sculpted the evolution of the first galaxies. So when you think about it, the hypernova really forces us to change how we see creation and destruction. They're not always opposites. It's this beautiful, powerful reminder that in the grand story of the universe, the most violent endings can actually be the spark for the most incredible new beginnings. The cosmos isn't just tearing itself apart, it's constantly and violently remaking itself.